Welcome back. Honors Algebra 1. This will be lesson 9.3a, guided practice problems, where we are going to work on solving quadratic equations by graphing. So we're going to start with a key concept chart, which you'll see here on the screen. We're going to take a look at the charts to understand how many solutions we will see on our graphs. So we're going to be graphing our quadratic equations set equal to y. If we look at the first graph on the left-hand side, we're going to notice that the parabola intersects the x-axis at two separate places. It has two x-intercepts. Those two intercepts will be the solutions to our quadratic equation set equal to 0. That will be the zeros of the function. So two solutions if the parabola intersects the x-axis twice. The second middle graph shows the parabola touching the x-axis only in one place. So there will be one zero of the function, there will be one x-intercept, there will be one solution then when our quadratic equation is set equal to 0. Our last graph, you'll notice, is a parabola that never touches the x-axis. It has no x-intercepts. Therefore, there will be no solution to our quadratic equation when set equal to 0. All right, let's see how this key concept chart can be used to solve quadratic equations by graphing. Here's our first problem. It will be in your textbook above example number 1 in our lesson 9.3. So we're to solve x squared minus 6x plus 5 equal to 0 by factoring and by graphing. So we're going to use the technique of factoring to actually see where we can place that parabola on our graph so we can see where the x-intercepts are and therefore the solutions to the equation. So we're using our factoring method, our x method, to find out that x squared minus 6x plus 5 equals 0 factors into x minus 5 times x minus 1 equals 0. And when we use our zero product property and set each factor equal to 0, we will discover that x is equal to 5 or x is equal to 1. Now, we're going to be creating a table of values in order to graph this equation and see those x-intercepts on our graph as the solutions to the quadratic equation. So we're going to rewrite our equation now. Instead of equal to 0, we're going to set it equal to y and make a graph for that. We know based on our factoring that the zeros of the function are x is equal to 5 and 1. We know we have two x-intercepts. Those are the zeros of the function, 5 and 1. The vertex will be exactly halfway between those two numbers. To find what that vertex x value is halfway between 5 and 1, we will add up 5 plus 1, divide it by 2, and we'll find out that that vertex then halfway between 5 and 1 is 3. So now we're going to create a table of values with 3 as our midpoint. That's our vertex x value. We already know the zeros of the function, the place where the parabola will intersect or cross over the x-axis is 1 and 5. We'll use a table of values with just those 3 points to determine 3 points on our parabola. That will be enough to be able to see where that parabola is. So you can see in the table of values how I have worked out my x and y values. Technically, I didn't need to fill out any information when I chose x is 1 and 5. I already know that the corresponding y value is 0. So I can actually just write that in without that middle work in the column. So there is my table of values then, and then here's my graph. 6x equals 1 and 5 are the x-intercepts. We notice that those are the values where the parabola crosses or intersects the x-axis. X equals 1 and 5 are the zeros of the function. That is the solution to the equation when the quadratic equation is set equal to 0. Notice our vertex does not show up in the values of x, but it is part of the graph. Okay, we're going to do 3 more examples to see how this works. Example 1 will be similar to what we just did. So we're going to solve x squared minus 2x equals 3 by graphing. First, we will rewrite the equation equal to 0 by subtracting 3 on both sides. Then we will use our x method to find the zeros of the function. So we factor into x minus 3 times x plus 1 equals 0. Set each of those factors equal to 0. X minus 3 equals 0, or x plus 1 equals 0, gives us x-intercepts of 3 and negative 1. So we will find our vertex halfway in between those two values. To figure out what number is exactly halfway in between negative 1 and 3, we're going to add up negative 1 and 3 and divide it by 2. That's going to give us a vertex of 1 for our x value. So you can see I've created my table of values. And notice the only middle part of the table of values that I filled out is when I'm finding the vertex y value. Notice that for x is negative 1 and 3, I automatically fill out my y is 0 because I've already determined that negative 1 and 3 are the zeros of the function. So I'm going to go ahead and plot the points that have shown up in my table of values. Again, I'm only going to use 3 points, the vertex and the zeros of the function. And I know I have 2 solutions. X is equal to negative 1 or 3, and my graph shows that. Now we're moving on to example 2. It will be a little different. Example 2 is going to show us what happens when there is only one value for x. So we're going to first solve our quadratic equation that is set equal to 0 by factoring, and that will factor into x minus 1 times x minus 1 is equal to 0. And when I realize that I have 2 factors that are the same equal to 0, I just simply set one of those factors equal to 0 and find out x is 1. When I only have one value when I factor my quadratic equation, that means that that one value is the vertex of the parabola. It will be the one and only one solution to the equation set equal to 0. So take a look at my table of values. I've plugged in 1 for my vertex x value and chosen a value smaller and bigger than 1, so I chose x is 0 and 2. I've worked out the values of y that correspond to those chosen x values, and I've plotted those points. Notice that the vertex is both the solution as well as where the parabola bottoms out. So when we have just one value based on factoring that solves the quadratic equation set equal to 0, our graph will touch the x-axis at only one point, and that one point will be the solution to the quadratic equation. So here we are with only one solution because there's only one x-intercept. Last example. This example shows what happens when we are not going to find any solution at all. So we're solving x squared plus 7 equals 4x by graphing. First, we subtract 4x on each side so we can get into standard form. We try to factor it, and it does not factor. That doesn't mean that there's not a solution. It just means that factoring will not be a way that we can use to graph our parabola. So instead of factoring, since that didn't work, I'm going to use negative b over 2a to find the vertex. I'll plug in my values for my b and my 2a. My a in this equation is 1. My b is negative 4, and my c is 7. I will not need to use the 7. So here we have my vertex at negative b over 2a, which is negative 4 over 2 times 1. And when I simplify that, my vertex x coordinate is 2. I create a table of values. I'm choosing values for x's that are the vertex, which is 2, and a number below 2, 1, and a number above 2, 3. That gives me my x values. And then I plug it into the equation to find my corresponding y values, and I've plotted the points. And you're going to notice that when I plot those points, I have a parabola that's opening upward above the x-axis. There is no x-intercept. That means for this equation there is no solution. So to see what we're doing in this particular lesson, I'm going to scroll back to the beginning here, and we're going to take a look one more time at our key concept. And we notice that when we graph our quadratic equations, and the parabola that we see when we graph it, if it intersects the x-axis at two places, we'll see two solutions, and those two solutions will be the x-coordinates of the x-intercept. If when we graph our equation, there is only one value of x, then that means that there is one x-intercept, one solution, and our graph will touch the x-axis at only one point. Finally, if when we graph our equation, we find that there are no x-intercepts, that means there will be no solution. All right, it is time now to begin working on your homework assignment for this lesson. Thank you.